Okay, here we are for example 2 from chapter 19, and we're given a totally blank table, so it's our job to completely fill this thing in. So let's go ahead and look at the scenario that we're provided here. A high school principal believes that when the SATs are given, the group consists of 10% freshmen, 10% sophomores, 40% juniors, and 30% seniors. The group that just took the test consisted of 12 freshmen, 18 sophomores, 45 juniors, and 25 seniors. Using a 10% level, test the principal's conjecture. Okay, so first of all, we're given the different levels in high school. So let's go ahead and fill them in. Like the freshmen are in our first group, the sophomores, the juniors, and then the seniors. And then we always just need to make sure that we have the same total. Remember that if we just kind of like make this a little bit thicker, when we go, that was terrible. When we go to our calculator, we do not put the totals in. I don't know what my problem is, but we don't put the totals in the calculator. So I just want to make sure that when we do this, we're all on the same page. All right, let's do observed first. That would be the people who actually took the SAT. So there were 12 freshmen, 18 sophomores, 45 juniors, and 25 seniors. And if you add all that together, that gives us a total of 100 students who took the SAT that day. Now it's our job to figure out how many were expected to take the SAT. Remember that when someone believes a distribution follows a certain percentage, that's the model. So the principal's percents are the model given. Okay, so I want you to think that if I'm being provided a model, then it may not be direct counts, but I might have to figure out what the values are that would go into that expected column. Now, we know the total has to match. So lucky us, we're going to multiply each one of these percentages by 100, which mathematically is actually not as challenging as we would think. So we take the total and we multiply it by the percent he thinks is in each category. So it would be like 100 times 0.1 for 10%, which gives us 10 students. And we're going to go down the line and keep doing the same exact thing. 100 times 0.2 for 20% tells us that's 20 students. We're going to keep going. 100 times 0.4, 0.4 gives us 40 students. And one more time, we're going to go 100 times 0.3, which gives us 30 students. Okay, so right now we have values we can put into our observed and our expected columns that are going to make sure our calculator understands what's going on here. As well as, I just realized I made a mistake in the previous example because we need the degrees of freedom, and y'all are going to figure it out when we get to the calculator part. Okay, so in this particular example, I'm going to make sure that we talk about the degrees of freedom, number 1. And number 2, we need to write our hypotheses out before, okay? So this says students, so let's say the distribution of, let's call them SAT takers, right, is consistent with the model. Right, it is consistent with what the principal said. And then our alternative is the distribution of SAT takers is not consistent with the model. So we have the idea that the data does follow the prescribed model. That's our null. And then the idea that the data does not follow what the principal said, which is the alternative. So what we need to do now is put our information into list 1 and list 2. So we would run our chi-squared GOF test, where our observed are in list 1, our expected are in list 2, and our degrees of freedom is the number of categories minus 1. There were 4 years in high school, minus 1 gives us degrees of freedom of 3. And then we end up with a chi-squared and a p-value. So the chi-squared in this case is 2.0583, and the p-value is 0.5604. So over here on the bottom, I'm just going to make a statement that this p-value is greater than the alpha we were given of 0.10 or 10%. So unfortunately, we would fail to reject the null again. So what we need to do here is try to write our conclusion as a failure to reject. And if I remember correctly, this entire chapter is failing to reject, and that's very boring, so I apologize for that. But that means that there is not enough evidence. I don't mean that every problem fails to reject. I mean that every single example I wrote fails to reject. Right? So there's not enough evidence to show the distribution. So I'm going to rewrite the alternative of SAT takers is not consistent with the model. So the numbers are too close to what the principal said to claim any different. I hope this makes sense. Okay, I so apologize for leaving the degrees of freedom off in the previous video. I will make a note when I post it online. Good luck.